Hi, let's go through the notes for section 1.4, sets, inequalities, and interval notation. We can extend our equation solving skills to solving inequalities, and that's what this section is all about. Our first definition, inequality. An inequality is a sentence containing one of these statements: less than, greater than, less than or equal to, greater than or equal to, or not equal to. So again, we have less than, greater than, we have less than or equal to, and greater than or equal to. Greater than or equal to. Okay, let's talk about each one. So first we have less than. Less than means a number is strictly less than whatever number we're stopping at. Now that stopping point isn't included, it's just letting us know the number is smaller than that. Greater than are the numbers that are larger than a number we're comparing it to. So if they're larger, they're going to go towards bigger numbers. To help us, it's helpful if we think of a number line. To the right of 0, we have our 1, 2, 3, 4, and so on. To the left, we get our negative numbers, which would be smaller. As you go towards the left, they're smaller, and as you go towards the right, they get larger. All right, moving forward, continuing on, we also have less than or equal to. So when you have an equal to, that means that whatever number you start or stop on, that number is included. Same thing for greater than or equal to. Whatever number you're talking that are greater than, if you have a number you're stopping or starting on with a greater than or equal to sign, that number will be included. Okay, moving forward. Definition of solution of an inequality. Any replacement or value for the variable that makes an inequality true is called a solution of the inequality. The set of all solution is called the solution set. When all the solutions of an inequality have been found, we say that we have solved the inequality. Let's do an example. Our instructions tell us to determine whether the given number is a solution to the inequality. So we're given a number and we want to test if it holds true. If it gives us a false statement, then that would not be a solution. So let's take that first one. We want to take that x plus 3 and want to replace the x with a 5 so that we have 5 plus 3, and we want to see if it is smaller than 6. So let's check it out. 5 plus 3, well, that gives us 8. Is 8 less than 6? No, right? It's larger. And if you're ever in a bind thinking, well, does it make sense? If you think of money or cookies, it always tends to make sense. So if you think $8 is less than $6, no, right? So not a solution. Now take a look at the next one. So same deal, we have our equation and it's telling me to test 1. I want to replace 1 with x so that I have 2 times, instead of x, I will write 1, minus 3, and I want to see if it's greater than or equal to negative 3. All right, well, 2 times 1 is 2, minus 3. 2 minus 3 is negative 1, and I want to see if it's bigger than negative 3. And yes, it is bigger. If you're ever unsure, you can draw them and compare. I have 0, negative 1, negative 3. Negative 3 is a larger number than negative 3. So it is larger, it is greater than, so yes, it is a solution. Next one, I want to test 3. I want to test 3 into my equation. So that we have 4 times, instead of x, we'll write negative 3, minus 1 is less than 3 times negative 3 plus 2. And I want to see if this inequality holds true. Is it less than or equal to? Well, let's see. 4 times negative 3 is negative 12 minus 1. And I want to see if it's less than or equal to 3 times negative 3 is negative 9 plus 2. 12 minus 1. When you're subtracting with negatives, remember you always add the opposite. So we get negative 13 less than or equal to negative 7. Is negative 13 less than or equal to negative 7? Yes, it's less than. So yes, it is a solution. Next example. Graph the inequality on a number line. Okay, so let's go ahead and do A. Let's graph a number line. So number line runs horizontally. To the right, I always like to write a plus, to the left a minus. Okay, and it doesn't matter. Well, I guess it kind of does, but you want to work mainly with the numbers you're working with. It's not necessary to always draw a number line starting from 0 or from 1. So if I'd like to, I can write a little 0 placeholder, label 2. All right, it's saying that x is greater than. So if it's greater than, what numbers are greater than 2? Well, 3, 4, 5, and so on, to continue forever to the right. And because we have a greater than, we're going to use an open circle. Next one. We want to draw a number line, and I want to graph 1. All right, so you don't have to draw 0, but just so we have a place value. And I want to find the numbers that are less than or equal to 1. So because they're less than, we're going to shade towards the left. And because there's an equal to, less than or equal to, I'm going to use a closed circle. All right, you might be asking yourself, or maybe you might remember from your past math courses, but maybe you're thinking, hey, where is she getting these circles that are closed and open? So let me explain that to you. When we use numbers that are considered to be open intervals, that would be an example of a less than or a greater than. We're going to interpret them with open circles. Similarly, or maybe I can say in the opposite sense, if I have a less than or equal to or greater than or equal to, if I have that equal to, I want to use a closed circle, a filled-in circle. That lets me know what we're looking at. Inclusion or no inclusion. And that closed one, that closed circle is called a closed interval. And we'll talk more about open and closed intervals as we proceed with the section and talk about interval notation and set builder notation. But we'll build on that. That's okay for now. Key terms. Graph. The graph of an inequality in one variable is drawing on a number line that represents the solutions. Set builder notation. When we write a solution, the set of x less than 4, using set builder notation as x such that x is less than 4. This is read as the set of all x such that x is less than 4. So my little rule for set builder is you're going to use curly brackets, and then you want to write the letter you're working with. It can be x, but it can really be any other variable, any other letter in the alphabet. You're going to draw a line, and then you're going to write your answer, whatever it may be. x less than 4 like we have here, or any other number you might work with. That's set builder notation. So remember, it's always curly brackets, your letter, and a line. Next, we have interval notation. Interval notation uses parentheses, that's for open intervals, such as your less than and your greater than, and brackets, that's your closed intervals, your less than or equal to, or your greater than or equal to, and closely parallels a graph of an inequality on a number line. So interval notation is a good way to kind of summarize what you see in a number line. Think of it as a number line summary. All right, so here we have a visual representation of what each one is. So if we have interval notation, if we have something like this, we see that translates into this. It's telling us we're starting at A and ending at B, and we use parentheses. Parentheses because there's no equal to in our statement. Let's take a look at another one. Let's take a look at this one right here. We have a little mixture. We have a bracket and a parentheses. Notice how the A has no equal to, and it uses a parenthesis, and the B has an equal to, and it uses a bracket. This translates to this image. It tells us where we start and where we end. What if we have an image that goes on forever? Let's consider this. Let's take a look at B, or this one here. We see we have an infinity. It has a negative infinity because we see it continues forever on the negative direction. So we use a negative infinity, and infinities always use parentheses. Doesn't matter if it's positive infinity or a negative infinity. And here we're stopping with B, and it has a less than without an equal to, so that translates to a parentheses. And last case that I want to talk about is, what if your answer is the entire number line? Well, that would be all real numbers. We'll write in set builder, just write all real numbers, and our entire line will be highlighted. Moving forward, an example, write interval notation for the given graph. Okay, so let's take a look at this first one. All right, so for this first graph, and the answer is there. We see that we read our number lines from left to right. Just like we read books, right? We read them from left to right. So we interpret our number line from left to right. We see that we start with -2 and we end with +4. So that will mark on our answer. So we start with -2 and we go all the way to 4. You see how this -2 has a parentheses that translates into our answer? And you see how this 4 has a bracket that translates into our answer too, just like we see here. Let's take a look at the next one. Notice how we have this arrow here that continues forever to infinity. This lets us know that it goes forever to infinity towards the negative direction. And then it stops at -1. So we interpret that in our reading. Now to write in interval notation, we read from left to right, so we will interpret this from left to right. So from the very leftmost point, we see we have an infinity, so we go to negative infinity, and then we stop at -1. Infinities always have a parentheses. Now I'm left to wonder, is that one going to use a parentheses or a bracket? Let's take a look at our graph. We see we have a parenthesis, so we'll use a parenthesis as well. Okay, let's add to our little chart about open and closed intervals. So for open intervals, we talked about that that's when I have a less than or greater than without an equal to. When we graph, we can use an open circle, or we can also use a parenthesis, like we will see in our interval notation. In closed intervals, which means that number is included, that will be when my statement has a less than or equal to or greater than or equal to, which will be represented by a closed circle, or if you want to, you can also graph it with a bracket, which will translate into your interval notation. This is important to have it handy. That's a big question I see in class, and I know I don't see you very often. So it's good to have this handy. Maybe keep it on a post-it and just have it next to you as you do your homework. I think that would be helpful. Here's a quick note. The two inequalities are equivalent if they have the same solution set. For example, the inequalities x is less than 4, x is greater than 4 and 4 is less than x are equivalent. So notice if you look closely, x has the larger opening and 4 has the smaller opening. Same thing here, 4 has a smaller opening and x has a larger opening. The values are just swapped. But notice that whether it had the larger or the smaller opening, that stays the number. If I would make a suggestion, try to always write variable, then your sign, whatever it may be, inequality sign, and then your number. The way you practice it is with the variable first. So if you're in a situation where you have the number first, take a moment to rearrange it and create an equivalent statement. A definition of addition principle for inequalities. For any real number, a, b, and c, a is less than b is equivalent to a plus b is less than b plus c. A is greater than b is equivalent to a plus c greater than b plus c. Similar statements hold for less than or equal to or greater than or equal to. So this is similar to what we saw in the past to the addition principle of equality. And that lets us know what we do to one side, we must do to the other. Let's see it in action. Let's do this first example. All right. So I'm asked to graph the equation, solve, and graph. Okay, so I want to solve, so that means get x by itself. So I must move that 5. I can move that 5 by making it 0 by subtracting. And what I do to one side, I do to the other. 5 minus 5 is 0. 1 minus 5 is negative 4. So I'm left with x is greater than negative 4. Let's graph it. And again, with your graph, when you do it online in your online homework, you'll have graphs. So you can just click your mouse and drag it to what you need to do. For here, let's just use the number we're working with. So negative 4. We want numbers that are greater than negative 4. So greater would be towards the plus side. Forever. It doesn't tell us where to stop. We have a greater than without an equal to, so you can use a closed circle or a parenthesis. Let's do a parenthesis. And that's our answer. We solved it, and then we graphed it. Next question. All of our rules from equality extend to inequalities. So we have our addition rule and our multiplication rule that we can bring over. All right, so we're asked to solve. So let's get x by itself. Treat your inequality as an equal sign. Sometimes students find it helpful if you draw a line through it. Okay, let's continue. So we want to get a variable by itself. So let's go ahead and move our numbers. So plus 2, that gives us 0, not 2. Plus 2, we get 1. And we're left with 4x plus 1 is greater than or equal to 5x. Let's move the 4x over, and we're left with 1 is greater than or equal to 5 minus 4 is just x. Now here is the situation where we might want to write an equivalent statement. Let's take the time to rewrite it with x first. So we have x, and do you see how x has a smaller opening? Let's keep it with the smaller opening. X is less than or equal to 1. Let's graph it. Okay, so x is less than 1. So we have 1, and the numbers less than 1 are to the left. And because it's equal to, I want to use a bracket or a closed circle. Let's go on to the next one. Let's solve and graph. I want to get y by itself. So remember, our rules of equality transfer over. So I can multiply the same thing to both sides, divide the same thing to both sides. All right, I want to get y by itself, so let's go ahead and divide by 3 or multiply by its reciprocal, however you like to think about it. Let's divide by 3, and we're left with y is less than 3 over 4 divided by 3. Well, we're left with a complex fraction. Don't let that throw you off. You know how to deal with this. So remember, that's just a division sign. Let's write it horizontally. 3 divided by 4 is divided by 3. Do you remember how to divide fractions? To divide fractions, our first rule is we keep our first fraction, we change our division to multiplication, and lastly, you flip your second fraction. So that we have 3 over 4 times, if I think of 3 as 3 over 1 and I flip it, that would be 1/3. So I have 3 times 1 divided by 4 times 3. 3 divided by 3 is 1, so we're left with 1/4. Our answer is now y is less than 1/4. Let's graph it. I have 1/4, and it's less than, so I'm going to shade towards the left, the smaller side. There is no equal to, so I will use a parentheses. Next one. Before we start this next one, I want to talk a little bit about what happens when dividing or multiplying by a negative number using inequalities. So dividing or multiplying with a negative using inequalities. Okay, so here is your rule. When dividing or multiplying with a negative, flip the sign. Let me go through a brief reasoning as to why. Let's take two numbers, 1 and 2. 1 is less than 2, right? But what if we multiply both numbers by a negative? And I now have, oh, let me change it up. Let me change up the signs. I think that would make it easier to keep track of. So let's say 1 and 2, but let's make the one negative. Okay, so I have negative 1 is less than 2, right? What if I multiply by a negative? 1 times negative 1 gives me 1, and 2 times a negative gives me negative 2. All right, what inequality will hold this true? Well, 2 is now the negative, so now that one's smaller. Do you see how your signs have changed? They completely flipped. So this is your rule. When you're dividing or multiplying by a negative, using inequalities, make sure to flip your sign. All right, let's do this next example. Solve a graph we have negative 5 is greater than or equal to 80. I think I meant to write a variable that I forgot. Let's make this an x. All right, I want to get x by itself, so let's divide by negative 5, divide by negative 5. So now I have x, and I'm going to draw a star so I don't remember my rule. So I don't forget my rule. And that gives me x is not greater than, but less than or equal to 80 divided by 5. That gives me, I'll have to think. So if it's 12, it's 60. So that means 14 would be 70, 16 would be 80. Okay, I was thinking 5 times 12 is 16. And if I'm adding 10 every 2 times, then that would be 5 times 14 would be 70. And therefore 5 times 16 would be 80. So answer would be positive 16. If we graph it, what numbers are less than 16? So that would be towards your negative side, and we'll use a parentheses. Ooh. Next one, a bit more involved. Remember, your rules of equality that you learned in your previous section still apply. If you ever get confused or if an equality just throws you off, remember, treat it like an equal sign. And if it's helpful, you can always draw a line through it. Okay, let's begin. Let's start off by distributing in that negative 3, so that I have negative 3x. Negative 3 times positive 8 gives us negative 24, minus 5x is greater than 4x minus 9. Let's combine like terms. I see that I have 3x and 5x that I can combine. Negative 3 minus 5 gives me negative 8x. Minus 24 is greater than 4x minus 9. Okay, let's get our x's and our non-x's together. So let's go ahead and subtract the 4, minus 4x, minus 4x. That's gone, it makes 0. 8x minus 4x gives me negative 12x. So that we have negative 12x minus 24 is greater than negative 9. Let's subtract the 24. Let's move it over. So let's add 24 to make 0. Add 24. And we're left with negative 12x is greater than negative 9 plus 24 gives us 15. Lastly, let's divide by that negative 12. So that I have x is not greater than, I'll draw my star so we don't forget, we're dividing by a negative. So x is less than 15 over 12, negative 15 over 12. Let's go ahead and graph it on my number line. So I have 15 over 12. It's less than, so we're shading towards our negatives. There's no equal to, so I use a parentheses. When you work with word problems, these statements represent inequalities. So this is super important, especially if you're going to go into stats. So if you're a student who's going to need to go over into statistics and transfer into your university of choice, this is something you'll see, these phrases, and this is something that my stat students do struggle with. This wording is just something that they aren't familiar with. So please take a moment to take a picture of it, or maybe make sure you write it down, because when you take statistics, if you take it, you will see these phrases. So, is at least, is it greater than or equal to? Is at most, is it less than or equal to? Cannot exceed is a less than or equal to. Must be between is usually some type of compound inequality. So, like this. Oh, I'm sorry, there was two different ones. Must exceed it is between. No more than is less than or equal to, and no less than is greater than or equal to. This is important, especially those last two. So I always see my students getting caught up on those phrases. So make sure you take a moment to just consider them, take them in for a moment. All right, that's it for the section. Now, something I like to do, especially when we're like in live class, I would take a moment to put you into groups and talk about amongst yourselves about what you learned. So we're not in class and maybe you don't have a buddy to talk to. So take a moment to talk about what you learned to yourself. Maybe go through each question and see if it's something that you need to remember. So I would for sure talk about dividing with negatives. I would talk about open and versus closed intervals. And I don't know, anything you find helpful to list. I just think it's nice to have those at the end so in case you have questions, you can see if there's something you covered in this section. All right, that's it. Thank you.